Hello, Year 10s. I hope you're doing well on your working from home days. We're going to be looking at C4.3 in today's chemistry lesson. So this is continuing what we were doing before the half term, and we're going to see where we can go from there. So we're looking at C4.3, which is how do balanced equations show us the amount of products and reactants in an equation. Now you'll remember we started this before half term, so we're just going to go a bit of a do now task just to check you're still on it. So I want you to find the relative atomic mass of carbon, oxygen, carbon dioxide and ammonium, and then find the number of moles of 3 grams of carbon, 16 grams of oxygen, 22 grams of carbon dioxide and 34 grams of ammonia. The equation you might need is at the bottom, which is number of moles is our mass in grams divided by the relative atomic mass. That's the part you're finding out on the left. Pause the video now, have a go at answering it, and then we'll go through the answers. So welcome back. So answers for the relative atomic mass. This is where we find the mass number on the periodic table. So for the element, it's just the mass number. For the molecule, we need to look at the total number of atoms there and add all the mass numbers together. So for carbon, it's 12, oxygen is 16, carbon dioxide is 44. We've taken the mass of one carbon atom, and then we've got 2 oxygen atoms and we've added them all together. So we've had 12 plus 16 plus 16 and we've got 44. And NH3 is 17. Again, we've taken the mass of 1 nitrogen atom and the mass of 3 hydrogen atoms and added them together. For our number of moles, we've used our relative atomic masses that we've just worked out and the equation at the bottom, and our mass in grams divided by the relative atomic mass. Our answers are there. We've got 0.25, 1, 0.5 and 2. Mark them yourself. Hopefully you've got them all right. If not, have another look at how we work them out. You might need to look back through your booklet. So we're now going to look at the worked examples from the bottom of page 61 and go on to 62 as well. So the first worked example, we have a question. We have iron plus chlorine will make iron chloride, and they've given us the balanced symbol equation, which is 2Fe plus 3Cl2 goes to 2FeCl3. And the question asks us how much iron chloride, FeCl3, can be made from 20 grams of iron. Now we're going to do this in 3 stages. Stage 1, we're going to convert the mass we've been given into moles, just like we did on the starter. Step 2, we're going to use the ratio from the balanced equation to find the moles of the product. This is where it gets a little bit trickier and a bit confusing, but we'll go through it. And step 3, we're going to calculate the mass of the product made. Now it's not a quick example, and the questions you do aren't quick either, but when you come to doing your exams, these will be worth quite a few marks. So first off, we're going to look at step 1. We're going to convert the mass given into moles. So we look at the question, and it tells us we've been given 20 grams of iron. We're going to use our equation we're using all the time at the moment is moles equals our mass in grams divided by our relative atomic mass. So we've been given the mass in grams, that is 20. We're going to use our periodic tables, so you can use the link I've set on Show My Homework to find the relative atomic mass of iron, and you should find that it is 56. So we're going to put those numbers into our equation, and we'll do our number of moles equals 20 grams divided by 56, and that gives us 0.357 moles of iron. We're going to make sure we keep that number written down somewhere, and we can move on to step 2. Step 2, we're going to use the ratio from the balanced equation to find the moles of the product. So this is where it can get a little bit confusing. So we're going to use the numbers we've got on our symbol equation. So here we've got the number 2 in front of iron and the number 2 in front of iron chloride. We're not bothered at all for this question about the number of moles of iron. So we're going to do some steps, and we just follow these steps like we did before half term. So we've got our balanced equation, which is going to look at the parts that we need. So we've got 2 Fe and 2 FeCl3. These balanced equations, these numbers tell us that mass is conserved and how much we have of each one in relation to the other. So we have 2 iron atoms will end up making 2 iron chloride compounds. And we're going to follow the same steps. We need to get our 2 to 0.357 for our iron. And whatever we do to one side, we do to the other side as well. So first off, we're going to divide it by 2 to make it into 1. So we're taking this 2 and we're going to get it into 1. So we're going to make it 1. We're going to divide it by itself. In this case, it is 2. So we'll divide it by itself to get it to 1. And we'll do the same to the other side. So we get 1 Fe, we'll make 1 FeCl3. All we've done so far is we've done the same to both sides. We've divided both by 2. We now need to get our iron to the right number of moles, which was 0.357. We've got 1. To get it to 0.357, we're going to multiply it by 0.357. So each stage we divide it by itself and then times it by the number of moles. So in this case, we're timesing it by our answer from step 1, which was 0.357. Now, very fortunately, they are both 1, so our answer is going to be 0.357 on both sides. And this is our number of moles of iron chloride that we've made. So we can now forget about our iron for the moment. We're not interested in that anymore. We just want to focus on the iron chloride. And that brings us on to step 3. Step 3, we need to calculate the mass of the product made. And we're going to use our equation again. Our moles equals our mass in grams divided by our relative atomic mass. Now we need to find the mass, so we need to rearrange the equation to make mass the subject. And that gives us our mass in grams equals our number of moles times by our relative atomic mass. We can now use the values from step 2 and the relative atomic mass of FeCl3. That again, we'll need to use our periodic table. We've got 1 iron atom and we've got 3 chlorine atoms. Our iron mass is 56 and our chlorine mass is 35.5. Remember, we've got 3 chlorines, so we add 1 iron and 3 chlorines, so 56 plus 35.5 plus 35.5 plus 35.5, and we can put that into our equation. So we get 0.357, our number of moles, times by 162.5, which was our relative mass of iron chloride, multiply them together and we get 58 grams of iron. We're going to go through another example as well before you have a go at doing it by yourselves. So we're going to have a look at another example, and this is calcium plus oxygen will make calcium oxide. And we need to calculate the mass of oxygen required to make 30 grams of calcium oxide. So this time we're working out the amount of reactant and not the amount of product, but the steps are still exactly the same. We convert the mass given into moles. We use the ratio from the balanced equation to find the moles of the reactant, and we calculate the mass of the reactant used, just like we did last time. If you're feeling pretty good and you think you can give it a go ahead and do it. You can then skip ahead in the video to see if you got the answer right. If not, follow along with it now and watch what I'm doing. So step 1, we're going to convert the mass into moles. We'll use our equation, our moles equals our mass divided by our relative atomic mass. And this is the relative atomic mass of our calcium oxide, because they've given us the mass of that. So we'll do 30 grams, which is our mass, divided by 40, which is our relative mass of calcium oxide. The mass of calcium plus the mass of oxygen, and we get 0.75 moles of calcium oxide. We're going to keep that 0.75 moles and remember it for our step 2. Step 2, we're going to use the ratio from the balanced equation to find the moles of the reactant. So we're going to be paying attention to the number 2 here, and there's no number in front of here, but just like in maths when we have algebra, we don't write a number when it's a number 1. So this would be 102. So we're going to need to follow it the same way as we did last time. We're going to write down what we've got. So we've got O2 and 2 CO2. So 1 molecule of oxygen will make 2 molecules of calcium oxide. We're going to do the same steps. We need to get our 2 to 0.75. So first off, we're going to take it to 1. So we're going to divide it by 2, or divide it by itself, to get it to 1. And we do the same to both sides, which gives us 0.5 O2 and 1 CaO. We divided both of them by 2. We're now going to do the same again to get it to 0.75. So we're going to times both sides by 0.75, which is our answer from step 1. And that gives us 0.75 moles of calcium oxide and 0.375 moles of oxygen. Do use a calculator for doing this. It is really helpful. You don't want to make a silly mistake at this point. I always use calculators when I'm doing these calculations just because it is so much easier, and I know that I'm less likely to make a silly mistake with my maths if I try and do it in my head. So we've now got our number of moles of oxygen, which is 0.375. So we're going to use that in our step 3. Step 3, we're going to calculate the mass of the reactant used. And we're going to use our equation again. Moles equals mass in grams divided by our relative atomic mass. We're going to rearrange it to make mass the subject, and that gives us our mass in grams equals our number of moles times our relative atomic mass. We're going to use our values from step 2 and the relative mass of O2. So we look on our periodic tables and we find the mass of oxygen is 16. But remember, we've got 2 oxygen atoms here. We've got that little 2 there. And that tells us that we need to add 2 oxygen atoms together. So we have 16 plus 16, which makes 32. So we're going to use our values. So we had 0.375 as our number of moles. We're going to times it by our relative atomic mass, which is 32. We'll do 0.375 multiplied by 32, and that gives us 12 grams of oxygen. So we need 12 grams of oxygen to make 30 grams of calcium chloride. Those are our worked examples done. Just remember to use our 3 stages. So we need to calculate the number of moles of the mass given. We need to use our balanced equation to work out the ratio, and we can then calculate the mass of either the reactant or the product. It's the same stages each time. It is a long process. It is tricky, but do it each step at a time. Make sure you're working out each thing and you will be absolutely fine. If you have any problems at all, any questions, please do email me or get in touch via Show My Homework, and I will endeavour to help you. Otherwise, have a great day. Best of luck to you. You will do fantastic, I am sure. I look forward to seeing you all in another 2 weeks when you're all back. Have a great day.